Peter, thanks so much for coming. I'm really excited to have you here and to be having this discussion.
Great. It's really nice to be here.
So I want to ask you the it might be one of the harder questions, but I really want to start there because it's urgent and important for me. In reading Image and Logic, um, the idea that science advances through instrumentation, experimentation, and theory to me was a revelation. And it was the first time I'd seen that kind of theory written down. Um, Maybe you could talk a little bit more about what led to that insight. Um, but the second half of the question is I want to know why that insight is still so underrated among scientists, why you think it is.
I think that in the translation of science into the public forum, the public space, typically what we do is we take results and we popularize them. We don't talk about process. And so, since theory is often the way that we conceptualize scientific results, experiment or the instruments that are used to do experiments, the experiments that lead to suggest new ideas for theory, confirm, refute, enable theories, tend to be pushed aside in favor of results. And so, we start out with an answer and then we try to explain it.
Mhm.
And not just in the relationship of scientific work to the public, but also in the way scientists often talk with each other. And so I think there's a tendency to collapse the way we narrate, the way we account for science, the way we do its history and sociology, the way we understand it in the media and its and reporting tends to minimize the more processual aspects of science. And so my training in physics was actually in theory. So I understand why theory is interesting and important. Physics has a pretty sharp distinction between, or many branches of physics between theory and experimental work. And but I wanted to, in my PhD thesis, which became a book, How Experiments End, to look at the world of experimentation not as an ancillary feature of theory, not as something that confirmed or refuted a theoretical proposition, but as a culture of science in its own right, a subculture, if you will. And so I began that work really trying to understand what persuaded experimentalists that something existed or a process took place in nature, and not just how it appeared to the theorists. You could say, if you ask a theorist in physics, why does an antiproton exist? They'll say, well, of course you have to have an antiproton. Relativity tells you that. As soon as you have a proton, you have to have an antiproton. But
Mhm.
for experimentalists, that was not at all obvious. They wanted to make one, to track one, to see the track that it left on in certain instruments, and then to use that to establish to their satisfaction that these things existed. It did not suffice for them that the theorists down the hall or on another floor said relativity plus proton equals you must have an antiproton. So I got interested in that. And in the course of working on that book, How Experiments End, I came to see that there was another feature, which was that there are instruments in a tradition of instrument making. For instance, instruments that make pictures that begin in some ways in the modern world with the cloud chamber at the turn of the 19th to 20th century. And then people who worked in that were led to develop the idea of using film and particles skittering along the surface of film as a way of making pictures. And then people looking at the film said, well, couldn't we make some solid medium that would combine the density of the film surface and the volumetric aspect of a cloud chamber and make something that became the bubble chamber. So you had this tradition of instrument making bound together by a certain way of thinking about how you demonstrate things and what counts as good evidence and the role of images and ways of interpreting images. And so that was in some ways a short version of how I came to think about these three cultures that are interconnected, these subcultures of science, but they're not necessarily the same thing. And the people who do one are not necessarily the people who do another. And in fact, they reinforce each other. And just the fact that they have different modes of demonstration helps give science its strength, like a brick wall where the bricks are not all lined up and the breaks in one line of bricks is not directly over that of another. That's how you gain strength in a wall. And so that's what appealed to me, is to try to understand this intercalated nature of the different subcultures of science.
I think it's such a powerful visualization. My only critique of the visualization aspect, the brick wall, is that you had it too far into the back of the book. I thought it was so important; it should have been right up in the front, and then and it should be, I think, a lot more widely understood. I'm surprised in doing these interviews how often this other discussion comes up, which is this. A lot of scientists I see referencing the Kuhnian view of paradigm shifts versus the Popperian view of, we're just going to make incremental progress, and they kind of use that mental model as a way to justify, you know, why they're doing what they think is, potentially paradigm shifting research, which is fine. I don't think that mental model has as much utility as the the theory that you've put forward in image and logic. I think there's actually a ton of actual utility that could guide scientists to make progress in their own careers. I think it could be um, useful in advancing fields, and I think it could be useful in increasing the dialogue between those different subcultures. So I'm like on a mission now to make sure that this has a wider audience.
That's
Um,
great. One of the things that people have responded to is, out of this picture of this tripartite description of instrument making, theorizing, and experimenting, I came to wonder how these different subcultures actually talk to each other, and that it's not like a radical translation problem as it was for Thomas Kuhn. It's not that people are switching from Greek to Russian, that they're actually, people develop the scientific analog, and in more than analogy in certain ways, of pidgins and creoles and intermediate languages that function at the boundaries. When people began to do nanoscience, and it was a combination of surface chemists, atomic physicists, and electrical engineers, they needed to develop a vocabulary that could allow them to move among these different fields without becoming expert at all three all the time. And so I used that to develop this notion of a trading zone, of certain regions where people develop a kind of exchange language sufficient unto the day to do the work that they needed to do and coordinate their efforts. And that happens in many areas of many of the most exciting, innovative areas of science, like string theory, which is at the boundary of quantum field theory on the one side and algebraic geometry on the other, or
Structural
many,
modeling of proteins, where all of a sudden
yes,
AI is coming in and changing the
this
entire field.
becomes much more regular. And these ideas of trading zones have come to be used by architects, for example, as they try to figure out how to do city planning, where you have residents and the government and regulators and transportation experts, and they need to talk to one another. Or environmentalists, where they have, you know, oceanographers need to talk to lobstermen, and they
Hmm.
have very different views about lobsters and how they procreate and where they go and migrate, and and that happens all the time. Soil scientists and farmers, and the Everglades, there's a very interesting set of studies of the Everglades where they use this idea of trading zone to talk about indigenous people in the Everglades, water conservationists, industry uses a lot of water from the Everglades, and they had to develop a proposal for how to think about water use in
Mhm.
this highly sensitive ecosystem with very different structures so that people could come to agreement, even though they may have had basic differences of fundamental values, about
Mhm.
sacred land or the values of conservation or responsibilities to the planet or economic growth, but they nonetheless could come to agreement about water use. So along with this three-part division of the kinds of activities that go into science came in image and logic, this notion of trading zones and the interlanguages that help facilitate them and allow groups to disagree about fundamentals and still get on with coordination nonetheless.
I think it's a beautiful idea. I'm going to tell you a quick story about my journey into this world because wasn't trained as a scientist. 10 years ago, my friend Eric and I were building this underwater robot in his garage because we wanted to explore this cave, and so we started building this robot, and then it was an ROV, a remotely operated vehicle, and we didn't have any money, so we were building it for very cheap, as cheap as we possibly could. And we ended up putting that project on Kickstarter and built this whole community and shipped these all over the world and started building this, citizen science community of explorers, and became a company, and we shipped thousands of these things. And then we got invited to these conferences with these oceanographers and explorers, and they put us up on stage and we told our story, and everyone was very impressed by what we had done. And it was all very surprising to me because, um, here I thought these were the leading ocean scientists and engineers in the world. What we did was with, massive constraints, and we just did it because that's the only thing we could do. And it, and in a way, it pushed on this whole area that turned out to be what I think is a very big blind spot, several blind spots to some of the work, the academic work that was happening around ocean science and exploration. And we were also at that time was kind of a buzzy period for citizen science. And everyone was getting excited about this potential for citizen science. And what I was trying to explain in my actual lived experience was that thinking of like the general public as like potential data collectors is actually the wrong way to view this. This idea of an amateur orientation is really important because it creates this trading zone, like you had used that language, for people from all sorts of different backgrounds to actually contribute and interact and communicate the science that's happening. So I love that idea of the trading zone. I think that's better than the wording I had been using around cultivating an amateur orientation in different disciplines, because um, it is an interaction that you're actually creating. So anyways, that's my story. I didn't know if you had a chance to read it, but that's what
I hadn't
that's
read
what
that,
brought
but
me to
I
this.
but I think there are many domains where citizen science does form a very productive trading zone between, with more the professionalized parts of the profession. There's this program you've probably seen called Galaxy Zoo, where
Of
people
course.
take hundreds of thousands of people have gotten involved with classifying galaxies that come out of Hubble and other pictures, and it turns out that even a amateur trained human observer can often classify with greater accuracy and reproducibility than an AI program, at least so far, or
Mhm.
recognizing whales by their markings and re-identifying those whales elsewhere in the world to understand their migratory patterns. Or, there are many examples of this protein folding and other things that have been gamified. So there are ways in which the scientists and other communities, whether they're people like farmers and folks who fish and commercially and so on, or whether they're amateur scientists, can actually productively work together in important ways.
Absolutely, and I think the astronomers and the birders are way out in front of everyone else on this. And the interesting thing about that is, if you look back into it, I have some books here. Like that's actually an instrument story. So like John Dobson creating the Dobsonian telescope and then incorporating CCD images and communicating over the internet. That was an instrument story. The birders too was, they were using optics left over from the, you know, World War One, and all these women went out and said, we're not going to shoot the birds, we're going to watch them and count them. And it's interesting because that too is an instrument story. And I think as different disciplines, protein folding is a good example, have started to create these amateur trading zones, I think we're going to see more interesting ideas and people inhabit those places. Like I think biology is a good place to look right now because there was this whole DIY garage biology movement and the iGEM competition that sprung up, which really had an amateur orientation. And now we see big companies like Ginkgo Bioworks, growing up as from iGEM participants. So I think there's a really rich area of structure on this kind of small instrumentation, this kind of like almost like low cost distributed realm versus, you've been spending a lot of time on the opposite end, which is this, big science, right? Like the Event Horizon Telescope. And, I think that's another incredibly dynamic place. So I'd love to talk about that. When you got involved, I know this is an amazing Netflix video now. What were you thinking about the project when you first got involved with it? What did your vision for the film entail at the early stages?
Well, I'd step one step back of that was in 2015 or so with some colleagues at Harvard from different fields, from physics, astrophysical theory, astronomical observation, mathematics, and there's 6 of us. And we thought we'd like to have a center for the study of black holes. We called it the Black Hole Initiative, because we believe that these objects, the most strange and mysterious and in some ways productive objects out there in the world, I mean, they're really bizarre, were of interest to all these different fields in a way that, even though there are many things of interest in astronomy these days, people call it the golden age of astronomy, not quite in the same way. I mean, philosophers are not that interested in neutron stars, even though neutron stars are kind of amazing objects and quite
Mm-hmm.
important in the universe. But black holes do. Black holes have gotten the direct and strong attention of the mathematical community, the philosophical community, physics, astrophysics. They help shape where stars can form. They're at the center of every major galaxy in the observed universe. I mean, they have a tremendously important role in all these different ways. And we thought it would be great to have a site where we could work together. I mean, a physical place, bring in
Mm-hmm.
students, and really try to change the field by working together on these things. So we started this, and we wrote a proposal to some foundations, and they were enthusiastic about it. And we began work in 2016. And that included, among other projects, a link with the Event Horizon Telescope. Shep Doleman was then the director of the project, which was, now there are about 300 people on it, but back then, I don't know, there were 50 or 60. I mean, it was much smaller. And then there was some theoretical work. Stephen Hawking was collaborating with one of our other founders of the Black Hole Initiative, Andy Strominger, and some others, Malcolm Perry, and that was a big project. And I had this idea of making a film that would be in some ways philosophical, but about about black holes. And I got very interested in working on the science side with the Event Horizon Telescope. So it really changed the direction of my research dramatically in 2015. And I had worked on some cultural projects about black holes before. I collaborated with the great South African artist William Kentridge on a project called The Refusal of Time, an installation with 5 screens and about the nature of time. And black holes figured in that. And I thought about it some, but this was really a complete plunge into the deep end of all that. And so I began filming just alongside the work that I was doing on the science side. And not knowing whether the Event Horizon Telescope would successfully be able to image a black hole, not knowing whether this work of Hawking and Strominger and Malcolm Perry would result in understanding something more about what's called the information loss paradox, this
Mhm.
strange disruption of what we think physics is about that black holes seem to present. And but I thought it'd be interesting to document this as we went along. And then many things happened along the way, and the work with Strominger, Hawking, and Perry was very successful. And in 2019, we issued the first image of a black hole, the one that's behind me here, of M87. And these were, big events. And in the course of it all, Stephen Hawking died. And I mean, a lot of things happened. So it wasn't something that I could have scripted. It was looking at, I thought what I wanted to do was to show science unfolding without
Mhm.
knowing where it would end up. Not saying, here's the picture of the black hole, how did we get here? But all along the way, not knowing until that image crystallized on the screen for the first time in 2018. I was filming then, so it's preserved in the film of that moment when we first saw an image of a black hole. And I thought that would be much more interesting and exciting than the retrospective story, the how did we get here? Instead, I wanted to see what's happening and the fearfulness, the anxiety, the excitement, the human and participatory feel of working on these projects.
It's an astounding film, and I encourage everyone to watch it. First of all, it's on Netflix. It's easy to find. What was so striking to me was exactly what you said, what you were showing the process unfolding, and I've been calling this science through time, like actually trying to show the whole process of science, where you're showing the question, you're showing the pursuit, you're showing the struggles, um, and you're showing the frustration, and you're showing the breakthroughs. And it had all of that, and it was a wonderful incorporation of the kind of the theory that you put forward in image and logic, where you have the theorists on one hand who are working on their angle of the problem.
Mhm.
You have the instrument makers on the other hand, and the experimenters on the other hand. It brought all of that together. So it's interesting because it seems like so many of those ideas actually came together. The question I have is, why is this idea of documenting and explaining science through time so rare when we know this is effective? And some other examples I'll show. I interviewed the director Jeff Orlowski for this series, and he did Chasing Ice and Chasing Coral. And he's a filmmaker, and he just kind of similar to you embedded himself with these scientists and showed the whole process, created wonderful films. I think My Octopus Teacher is, although he's not a formal scientist, um, in some ways is really just asking a very specific question about the natural world, showing that process going back and forth. In the age of YouTube, when we could be easily documenting these every corner of the scientific universe, could be we could be creating, it doesn't even have to be films. Uh, I think it could be series or even YouTube channels. We've got tons of explainers. Why don't we have more examples of science through time?
That's a good question. I think that, there's an analogy perhaps in the way we run museums. When we run museums for the arts, if you go to the Metropolitan Museum in New York and see an exhibit on the School of Rembrandt, or you go to the ICA and in Boston, or the Museum of Modern Art in New York, you have an audience that is not by no means all artists or art historians, but they are addressing a curious and educated, engaged adult public um, in the process of understanding how art develops and unfolds. And whether it's Picasso and Braque, or whether it's the development of more contemporary art, or the Andy Warhol Museum in Pittsburgh. I mean, there's a sense of people being interested in the evolution of art over time. In science museums, they are overwhelmingly addressed to children, and they've served to be a kind of rainy day expedition. I'm all for scientific education for children. God knows we need more and better science education for kids that's more appealing and draws people more into science than is happening now. But in a way, the adults in the room have been left out,
Mhm.
and most adults don't go, minus children, to science museums. And the science museums, when they make exhibits, or they're when they have interactive things, or they have lectures, they tend to be addressed towards seventh, eighth graders. If I give a lecture at MoMA, no one says to me, make this understandable to a 12-year-old. But if I give a lecture at a science museum, they say, make this understandable to a 12-year-old. And so I think that in a way, film has followed that they become explanations. They are, you know, the race to DNA, the discovery of plastics. They start at the answer and then tell us what these are about.
Mhm.
And it's more uncertain. You have to have a real risk of failure. Not every scientific project succeeds, and putting your effort into making a film that may not go anywhere, um, where the end product is, what, we can't image a black hole, or what, this attempt to figure out whether there's enough storage capacity on the horizon of a black hole to record all of the ways that it was made, didn't work, got the wrong answer. Those could have happened. And I think that's, there's a way in which a combination, that somehow the idea that science is for scientists and children, but not for the culture as a whole, has sort of sunk its talons deep into the body cultural, so to speak. And we need to extract ourselves from that. I think pedagogical explanatory films that start at the end are fine. I mean, there are many good examples of it, but we need to have room for these more exploratory films, to using film or other forms of, or writing, or installations or exhibits, as ways of, as a form of inquiry, is trying to understand how science works and how the world works around us.
You're here. Um, I have two questions. I have to figure out which one I want to go, which direction I want to go in next. I think the thing I've been working on this website called experiment.com. I've been running this experiment foundation and trying to fund science in new ways. And it's a wonderful tool because it's functionally a grant proposal plus lab notes. So it's like two things that were normally hidden documents in science, and it brings them online and invites communities to form around these, to fund them, but also to participate in the research. And it's been a really interesting form to play with. It's, we've had moderate success. There's been 1,000 or so funded projects, um, but it's really hard to get scientists to pay attention to anything other than papers. They're so heavily incentivized to publish and to focus just on those kind of results. Like that's where the engine is. What role does changing the incentives, or could changing the incentives um, change the culture? I'll be a little bit more specific because the what role does new communication technology play here? Does
I
that make
think, one great example that I've seen of this was, we had a system of incentives in, say, the biomedical area, that rewarded people dividing up their papers and to get the maximum number of publications. And, people made fun of it in the midst of it, calling it salami technique, right? You sort of use the least publishable unit. If you could get 3 papers out of 1 paper, it would be better to do that so that you would have 3 papers on your CV rather than 1. Um, but eventually the Harvard Medical School and many other places now had decided to change the incentive. And they said for promotion to a certain rank, assistant, associate, full professor, you could have, you know, N1, N2, or N3 paper, whatever it was, 5
Mhm.
papers for this, 10 papers for that. Suddenly the incentive was very much turned on its head. Suddenly you wanted the best 5 papers you could produce, not 5 of the least publishable unit papers, but 5 really terrific papers that showed something important in each. And so overnight, you change the incentive structure for people in the medical school in their publication techniques. And that seems to me a very good example of changing the incentives that had a salutary effect on how people thought about publishing. It also, it coupled with, it had other benefits. It's something that's been well studied that young women scientists tend to publish longer and more, complete papers than a lot of their male colleagues because they were under such pressure and often discriminatory pressure that they felt they had to like super bolster their results.
Mm.
So this new system of incentives created a more equal platform for the for men and women young scientists to
Mhm.
advance, since everybody had now the same incentive to get their best papers out in their most developed, well argued, and documented form. So I think that what this shows to me is that it is possible to use the incentive structure in productive ways without abandoning the idea of publication. It's nonetheless shifting the incentive from multiplying just incredibly rapid, superficial papers to work of genuine substance.
Yeah, I agree, and I think that's actually closely related to the other ideas about pulling science into more into kind of the everyday life of people. I think there's a ton of potential there. Um, and I think that your film, to me, it's like it's very inspirational. I was sending it to my teammate Eric, and we're modeling, we're going to do this YouTube series as we build a pressure vessel that can test materials down to full ocean depth. And this is a real inspiration of how science communication should be done. So for you, I like this is kind of a personal question, but where do you go from here? I mean, you've had this amazing project that got to bring Stephen Hawking and all these other amazing scientists together, and you created this wonderful film that documented the moment. I mean, you have this incredible image that came out of it, and you got all the press. You've got this position at Harvard that's you're embedded in scientific instrumentation. That feels like the top of the mountain to me, but like how do you think about where to go from here?
Well, so my over the last 20 years or so, I've gone back and forth between writing and filming, and I see them not as, in competition, but rather as complementing each other. And that, I've written about state secrecy and, out of my interest in the history of physics and the development of nuclear weapons and how the model of secrecy in nuclear weapons then spread to many other aspects of our society. And I got, and then I made a film called Secrecy about national security, secrecy, and democracy. Uh, and then I was interested in the waste that's produced by weapons production and other forms of nuclear technology, and where that went, to look at the sort of the distaff side of nuclear, not the power generating, weapons producing side, but the waste that comes out of this. And so I wrote about that and this problem of trying to warn the future 10,000 years from now about where we had put our waste, since the half-life of plutonium of the weapon's sword is 24,000 years, you have to bury it for the long term and warn people against digging it up. And then
Mhm,
I made a film about that with my colleague Rob Moss,
mhm,
called Containment. And so, I see this back and forth as important to me. Right now, I have one project with Caroline Jones, who's an art historian at MIT and to whom I'm married. And it's called Invisibilities, Seeing and Unseeing the Anthropocene. And we're writing about the way images function to reveal or conceal
mm,
what's happening to our planet in the large, in the way it affects water, air, and land. So that's a project. I've continued with the Event Horizon Telescope, not so much on the filming side, but just on the science side of we're looking now toward the supermassive black hole at the center of our galaxy, the Milky
mm,
Way, called Sagittarius A star, and trying to see what we can see there and
mhm.
how we can study that. So those are some of the things I'm interested in. I'm trying to do some experiments with film, some short films. One that's purely using animation. It's still in the making stage, but I hope to finish that fairly soon. So I'm trying to explore, to try new things, and to see where they go.
Yeah, that's incredible. Well, I'm excited to see what comes of it. I think one thing I came across, and maybe this is, this is again my perspective of being an amateur and an outsider to to science, is it feels to me like we're amidst like a generational change, similar to the mid 19th century when the popular journals kind of came about and had this kind of bigger, broader aim of trying to reach more people. Um, it seems to me we're in the middle of something like that. I don't know if would you agree with that
That
analogy?
science is in some
It
ways a
it
golden moment of expansion and
I think it's in a yeah, I would, but almost a golden moment, but also like a transitory moment where it's learning to it's adapting to these new digital tools. I mean, so the way I just kind of was writing about this yesterday, on one hand, science wants to move slowly. It's designed to move slowly through peer review, and that's how it builds a firm foundation. But on the other hand, science wants to move faster, right? Like people want feedback, they want priority for their ideas, um, and I think that tension is as high as it's been since nature was introduced, and these periodicals that were aiming to we're publishing faster and aiming to reach a higher audience. And sometimes it seems to me that these kinds of big communication changes, the communication infrastructure of science, um, actually usually take a generation to take hold, or to kind of show the new path. I think we've seen this, I think, with journalism and movies, and there's been like a digital revolution. Like if you're a musician, 20 years ago, you were moving to LA or moving to Nashville trying to get, played. Now you're in your garage, making, making your music on Pro Tools and GarageBand and uploading it to SoundCloud and trying to get discovered. I think the pathway to becoming a practitioner of those arts has changed. I wonder if we're actually in the middle of a pretty a similar transition in science, where the pathway to scientific freedom or is also going to change. Um, I don't know. First of all, do you agree with that? Would you agree with that?
well, I do think there's some things that have changed in the digital realm that will affect many of the sciences, not maybe everyone, but many. And that is the development of the fast computation, massive storage capacity, machine learning, AI, that whole complex
Hmm.
that allows people to move back and forth among fields and becomes a kind of a a pass key to a lot of work in many different domains. The analog of the way digital marketing works in the commercial sphere. My my sister has a very nice toy, and children's oriented company, and I can talk to her about digital marketing, when thinking about when I was getting the first stages of getting my film out into the world.
Hmm.
And it somehow didn't matter whether she was making these beautiful jigsaw puzzles at the beginning of the pandemic, and I was working on getting a film out. It really was the same, many of the same tools, whether it's using Facebook and micro targeting and distributing these audiences, and then using algorithms to determine which of them is the most successful, and then reallocating. And there's a lot that's in common, and machine learning is like that too. I mean, there are people that use many of the same tools across many different domains.
Hmm.
And I think that that's interesting, because it's not what in philosophy we'd call ontological similarity. It's not that they're looking at the same things, but they're using many of the same tools. And that does change how the trajectory that people have and what kind of things you need for many domains in the sciences, whether you're in biology or physics or astronomy and so on. So I do think that there are these changes, and they do have an effect. And I agree with what you said about music and or filmmaking, right? I mean,
Hmm.
now you can use pretty professional editing tools on your computer at home,
Hmm.
and you can use Adobe tools or Avid, and you're working with many of the same tools that can be used for editing, films that cost many powers of 10 more than what you're doing. So I think that's interesting. And I think that is something that's shifting.
Cool, cool. Um, well, the reason I ask is because I'd love your perspective on this, right? Like, there's a small list of people who I put in your category. Like I don't know. Do you consider yourself more of a historian, a philosopher, or a scientist? I don't actually know which one you would consider yourself. Um, but whatever it is you're doing is kind of watching science from a long perspective. I mean, you're at the collection of scientific instruments at Harvard, and so you're surrounded by the material culture of science, and but you also have this kind of breadth because you're talking to folks in all these different disciplines. From that realm, I'm wondering where what you see for the future of science that perhaps some of us are not seeing. Like, what's a surprising insight or prediction you have for where science could go, the practice of science, that is not obvious to maybe someone who doesn't have your perspective?
Well, I think the one thing that I felt strongly, and this is more personal than general, but with the Event Horizon Telescope, is that the for example, the scheme. Lorraine Daston and I wrote a book called Objectivity,
Hmm.
about the way that the history of objectivity. You might think, well, objectivity, that has no history, that's just science. Well, it turns out that objectivity is something, a virtue that's comes to be valued in science fairly late. It was not something that Newton or Descartes were worried about, not because what Newton was doing wasn't science. It absolutely was, and of the first water, so to speak. But he was worried about other things. He was worried about quantification and prediction and precision, and using experiment in new ways, but not about objectivity, not about the idea that somehow our expectations might shape the results that we see, or that the role of images in establishing knowledge that wasn't dependent on us and our predilections. That's a 19th century problem. And only in the mid 19th century do you start to have people use objectivity in a way that's continuous with the way we use it today.
Hmm.
And in thinking about that, I mean, objectivity, Lorraine Daston and I argued, was, had sort of different stages. One of them was a very mechanical form, that you wanted to do everything you could to make nature write itself to the page, so to speak, with a minimum of intervention by us. Then there was a period where judgment came to be highly valued. And the idea that machine or procedural or protocol driven things were enough by themselves would not be sufficient. And in working on the Event Horizon Telescope, we found that thinking about things that way actually helped us sort out how we were going to try to show that this image was really an objective one. And that, we started out by dividing the team into 4 parts, and each of the teams worked in secrecy from the other and looking at the data through their own imaging techniques. And then we confirmed that were all getting something like this bright ring with a brighter crescent in the south. And that gave us hope that this was something real and not an artifact of our expectations. And then we said, okay, now that we've seen that, is there a way that we can sort of routinize this and let's just say to the computer, do the best job at reconstruction you can do without our using judgment. And so the coincidence of having these 2 techniques all work out seemed like a positive step towards our conviction that we had an objective representation of the distant galaxy M87's black hole at its core. And so, that's an example where the philosophical side, the sort of longer term historical philosophical side of science actually played a role in our thinking about image making, as part of the image team in the Event Horizon Telescope. And I think that, if I was to generalize that, I think that it is possible now for us to be thinking about science both in the midst of doing science and also trying to understand how it fits into a larger picture. And that may be something that can be very productive, not because science has to be the same as what was done in the past, but because we can learn from the way science and the philosophy of science inform us about the nature of scientific argument and demonstration. So that's something that I think is interesting. I think the idea for me, I think of a trading zone, and I think for many of the people that have used it in a variety of different fields, I think we are at a moment where different scientific fields are finding common cause and able to work together in the brain sciences, in the nanosciences, in string theory, in the environmental sciences. The great problems of global warming are fundamentally interdisciplinary. I mean, there's no way to understand what's happening to the atmosphere and greenhouse gases without economics and visualization techniques and data analysis and measurement and theoretical modeling and so on. It's really a conjoint activity. So I think that, I see science as in some ways moving in a fundamental way, not just at the margins, into interdisciplinary collaboration, which I think is very exciting.
I agree. And I also think, those, I would extend that, and this kind of gets back to what you were saying earlier about, I don't like to use the word public because I think it's too generic. But the boundary line between where science, like who's kind of traditionally been considered a scientist or not a scientist. One of the things I remember in The Edge of All We Know, I was watching it and thinking, when they split up into different rooms and did that, I remember thinking, wow, that's exceptional foresight and something I would never even have thought to do, just to confirm that kind of the objectivity of the observation. I thought that was really smart and surprising to me. I'm wondering if there was any thought put into studying the boundary of the science communication of the whole thing. For example, like could you have designed a study where you had a bunch of people who viewed the documentary versus people who just read the news in Scientific American? Like, could the impact and perception of science have been different because of this new way of communicating it? I think that would be really interesting, because I think like some of these major problems, like you brought up global warming and all these other things. I mean, we have this, I think it's a real crack in the foundation of science that, we're going to race to these vaccines, but half the country, isn't going to take them because they don't, trust the science or whatever it is. I think this kind of the the things you're thinking about, the ways to communicate it. I think there needs to be rigor and thoughtfulness applied there, and I'm wondering if that came up in any the discussions that you guys had about it.
Yeah, I mean, um, we do have a communication group, an outreach group, um, and we've gotten better at this. I mean, I think we knew that the image would make news on April 10th, 2019, when we first distributed it, but we had no idea that 1 billion people would see the image in 24 hours. And so that was a jolt to the system. And we've begun, developing more sophisticated visualizations to use, to have shared resources for people as they, and making things available in YouTube talks and various other forums. We've done recently some Reddit Ask Me Anything.
Mhm.
We've done, so we're still experimenting. We're, collaborating, making some educational materials with the Smithsonian. So there, I think that these are, um, I think we've made a lot of progress. I think there's a long way to go. We haven't done detailed studies of comparing the different modes, which is a good idea. Uh, but I think that science communication, just, you know, and as it is for science museums, I think there's a lot more space there than we've explored. I mean, I think that, there's especially now, I mean, where there's so much cynicism about science from so many quarters, not believing epidemiology or not believing, the function of masks or the vaccine or global climate change or, I mean, I think there's a lot of examples where people are alienated from science in some way. And I think there's anything we can do to draw people in to make them see science not as some cabal of experts, but rather as, ordinary reason applied systematically to the world, is good. I one of the things I did was to make an edX course, a free edX course, and when we run that, it's interactive. It's called the Einstein Revolution. Um, it's not as big as some, but each time 25,000 or so people participate, and so that's a way of engaging a broader number of people
Yeah,
in scientific thought and in a broader sort of cultural way.
yeah,
So I think that there are, that course tries to combine some physics and some art and some philosophy to try to use Einstein as a thread through modern culture from the late 19th century to the present in some way. And so
that's
I
cool.
think that these have possibilities, but I think we've only just scratched the surface.
I agree, and all the tools are right there, literally. I mean, behind your screen,
Yes.
available to everybody. Okay, so last question, and you've answered this in so many ways, but I always like to give people the opportunity to put a exclamation point on anything. Is what are your best ideas to make science better?
Well, I think one of the things that's very important is to make science seem like it's inviting. The door is open for people to join, and that we make sure that minorities and women feel welcomed into the domain of science and its different aspects. That there are encouragement in all the way down to lower grades. That our textbooks, especially in my area in physics, tend to be somewhat repellent aesthetically. They're incredibly fat, formal, bad illustrations. You open it up and you don't think that's what I want to do. You sort of have to think, I desperately want to do physics. And despite this book, I'm going to go into it. I think that there are things that we could do in the way we teach children science. I think there are outreach to adults. I think museums could do a better job of uh, bringing in the process-oriented aspect of science, to engage with continuing research, to discuss failures as well as successes, to track things, to show it as a human activity and not one that is a few people in lab coats in some isolated other place. And I
Mhm.
think it's important for the success of science, and it's important for the success of our world. If we're going
Mhm.
to, you know, if we make it out of this pandemic, I think I'd have to say we sort of squeaked by. The science was great on the vaccines, especially, but
Mhm.
we have a large amount of vaccine, hesitancy, and I don't think we've been very successful in communicating how science works or why people believe that it works. We have
Mhm.
people will say, trust the science, but it shouldn't just be a matter of belief. It should be a
Mhm.
sense that, okay, you do a test. Here's why you do a test with placebos, and how we come to believe that, that
Mhm.
this works and that doesn't. And that
Mhm.
not everything that was tested worked out well. I mean, people had good ideas that didn't succeed. The mRNA virus, the approach to countering the virus was amazingly successful. And I worry about next time, that there will be other pandemics, and
Mhm.
and the global climate change is not about to be solved. We have a long way to go. But
Mhm.
in order to do that, we have to bring along, there has to be a sense that people have a stake in the science, that
Mhm.
that it's something that belongs to them too. It's not
Mhm.
a cult. It's not an isolated, different kind of person, but something that is inviting at every level,
Mhm.
from public understanding to training scientists, to science in school children, to the representation of science in film and theater and books. And I think all of these things play a role.
Here, here. Well, that's great, Peter. Thank you so much for your time. And like I said, I keep recommending your books. I think they're fantastic, and of course, the documentary. If folks haven't seen it, um, I think it's one of the best science documentaries ever made. So,
Well,
congratulations,
thank you
and
very much. I
it's
appreciate it, and
fantastic.
your kind words about the books and The Edge of All We Know. And I look forward to hearing more from your series.
Sounds good.